We know a lot about Saturn. We know it's a gas giant surrounded by a system of rings. We know it's orbited by a whopping 62 moons. We even know that its north pole has a mysterious hexagonal cloud pattern. Despite everything we know, we still don't have the answer to one very simple question. How long is a day on Saturn? On rocky planets such as Mars and Mercury, the length of a day can be easily calculated through simple observation. But for gas giants like Saturn and Jupiter, figuring out day length is a little more complicated. In these planets, the interior layers of metallic hydrogen are obscured by thick clouds of gas that rotate at different speeds than the planet itself. What researchers can do is track the magnetic field generated by the spin of the planet's interior. For most planets, the axis of the magnetic field is offset from the axis of the planet itself. Earth's magnetic field, for example, is tilted 11 degrees from its rotation axis. Jupiter's is 9.2 degrees. This offset causes the magnetic field to wobble around the planet at regular intervals. Each wobble causes a distinctive swing in its radio emissions, allowing researchers to track the length of the planet's day. For Jupiter, Uranus, and Neptune, this method worked perfectly. Saturn, however, wasn't so cooperative. In 1980 and 81, the Voyager 1 and 2 spacecrafts were the first to attempt to measure the rotation of Saturn's magnetic field. Based on those measurements, the length of a day for Saturn is 10 hours, 39 minutes, and 24 seconds. But when the Cassini space probe made an attempt in 2004, its readings suggested a Saturnian day of 10 hours, 45 minutes, and 45 seconds. Nothing in the solar system could cause the planet to slow down so much, so fast. So researchers concluded that the measurements from both Voyager 1 and 2 and Cassini must be wrong. The problem seems to lie in Saturn's magnetic field. Unlike the other planets in the solar system, the magnetic poles line up almost perfectly with the planet's rotational axis, making it incredibly difficult to accurately measure the wobble of its radio emissions. Researchers hoped that Cassini's final passes between Saturn and its rings, 12 years after the first measurements, would allow them to better measure the magnetic field's tilt and its related radio waves. The initial passes were promising. There was evidence of a wobble in the data that scientists believed could be linked to Saturn's rotation rate. However, toward the end of Cassini's final passes, researchers realized their radio wave data were showing differences in the magnetic field's rotation rate from season to season and between the northern and southern hemispheres. This meant that something other than Saturn's core was affecting the rotation rate of its magnetic field and accompanying radio waves. Researchers believe these low-frequency radio waves are affected by the density of electrons in Saturn's magnetosphere, and therefore are not a reliable way to measure the length of its day. At the time of Cassini's last dive, the mystery was still not solved. However, all is not lost. The amount of data collected during Cassini's final passes was immense, and it will be years until all of it is properly analyzed. An answer could still lie somewhere in those data. Until then, researchers will continue their work, hoping that eventually an answer to the question, how long is a day on Saturn, is, well, clear as day.